In this video, we'll look at how to calculate a cumulative frequency and then use it to plot a graph to represent it. We'll then use that graph to estimate the median, quartiles, and the interquartile range. Then we'll see how data can be plotted on a box plot and compared to other box plots. And then finally, look at how histograms are created to represent data that has unequal class intervals. Here we can see a table of data that shows how a group of people replied to a survey that asked how long they exercise for each week. We asked to create a cumulative frequency for this data. As we can see, this data is grouped in class intervals, which are spaced evenly at 2-hour spreads. The cumulative frequency is where the class interval increases in size as it goes through the data to include the data that preceded it. Therefore, we can see that the first category of greater than 0 and up to and including 2 still has 17 in. However, the next category is a combination of the first two, and therefore states that greater than 0 and up to 4 will equal 49. Greater than 0 and up to and including 6 will equal 100. Greater than 0 up to and including 8 will equal 220. Greater than 0 up to and including 10 will equal 235. And that lastly, greater than 0 up to and including 12 will equal 240. If we check with the total of the frequency, we can find that it adds up to 240. So this works as a double check for us. This is the creation of our cumulative frequency. Now, let's look at how we go about plotting that on a graph. Here, we can see the same data that we've just calculated, and we're asked to plot these points as a cumulative frequency graph. When we plot these points, we must always remember that we plot it at the upper bound of the class interval. This is to include all the possible data within that class interval. You can connect it to 0, 0, but it isn't requested, so you won't lose any marks if you don't do it. Remember to join all the data points with a curve drawn freehand rather than with straight lines. We're asked to calculate the median using this cumulative frequency curve, and we can do that if we work out what position the median will be in. This can be done by 240 divided by 2, which gives us 120. So we know that the median will be between the 120th and 121st piece of data, and we can plot this on the graph like this. By creating the line from 120 across the graph and then reflecting it down, we can say that the median is roughly 6.5 hours of exercise. Next, we're being asked for the upper and lower quartiles. This is the middle of the data above the median and the middle of the data below the median. So we can draw lines from 180 and 60 across to the graph and then down to discover that the lower quartile is 5 hours of exercise and the upper quartile is 7 hours of exercise. We're now asked for the interquartile range, and it's worth knowing that the distance between these two quartiles would be 2. The interquartile range is often used as a better measure of how representative the median is, as it contains the 50% of the data that's grouped around the median, and therefore it's not affected by any outliers. We'll use these measures in the next display of information, which are called boxplots. To create a boxplot, you'll require 5 pieces of information, which can also be gained from a cumulative frequency graph, which is why these are referred to often within the same area of statistics. These 5 pieces of data are the lowest amount, the lower quartile, the median, the upper quartile, and the highest amount. These are plotted on our graph as vertical lines. Here, the lowest amount is 68, the lower quartile 74, the median is 82, the upper quartile is 88, and the highest amount is at 102. There is then a line drawn to connect the upper quartile and the lower quartile, which will create the box in the name of the graph. The median will also be included in this box, but not necessarily in the middle. The outer bounds are connected to the quartiles by lines from the centre of their line to form tails, and the length of these tails suggests how far from the median the outer data pieces are, and it shows how consistent the data is. We're then given another box plot to compare with the first and make comments on the difference between the sets. What I always tend to suggest is focusing on the median and the interquartile range. For example, in this case, we can say that set B has a lower median, but the interquartile range is similar. It could also be said that the range in set B is far larger, suggesting some possible outliers in the sets. Next, we'll look at histograms and why they're good for showing data with variable class intervals. In this question, we'll be looking to complete a histogram on this set of data. This type of graph often tends to get confused with bar charts, but they rely on the area of the bar created and the data being continuous rather than discrete. This means the data can be taken from any values. For instance, the number of students in a class is discrete, as you can't have 2.75 students, it's either 2 or 3. Continuous data could be the student's height, which could be any measurement and any further refinement for accuracy. For instance, 2 students could measure 150 centimetres, but one may be 149.8 centimetres tall and the other 150.3 centimetres tall. Both of those could be refined to 150. You can see the frequency table here, and we can see the categories don't seem to be even. We can create a frequency density by dividing the frequency by the width of the class interval. So we'll calculate the width first. Then, the frequency density for the first class interval would be 5, as 10 divided by the class width of 2 gives us 5. For the second, it's going to be 12 divided by 2, which gives us 6. For the third, 16 divided by 2 would give us 8. Then 36 divided by 4 to give us 9. 24 divided by 6 to give us 4. And 4 divided by 4 gives us 1. We can then map this on our graph with the width of the class interval on the x-axis and the frequency density on the y-axis, like this. That would mean that this would be the first bar, this would be the second, and the third, and so on. This is a better visual representation of the data as it compensates for the wider class intervals. In order to calculate the bar, you can reverse this by multiplying the class width by the frequency density to find its value, or its area, which we're going to use to answer the next part of the question. We're asked to estimate the percentage of data that is above 8 kilograms. As this type of question is usually raised from just the information on the histogram without the data available, I'll use the histogram to show you the process to calculate it. Firstly, we can see we can split the category in half, that is from 6 to 10 kilograms. This means that we can estimate there's going to be 2 times 9, which will be equal 8 pieces of data, above 8 kilograms in this bar. We can then add this to the 4 by 6 in the next category, which equals 24, and 4 by 1 in the last category to equal 4. This gets us a total above 8 kilograms of 46 pieces of data. We can add all those below the 8 kilograms to get an overall total. So we'll add 10 plus 12 plus 16 plus 18 in the other half of that bar, which added together gives us 56. We can add this to the 46 above 8 kilograms to get a total of 102. 46 divided by 102 times 100 will give us the 45% that we can estimate is above 8 kilograms. In this video, we looked at how to calculate the cumulative frequency and then plot it on a graph to enable us to find the median, the upper and the lower quartiles. We then showed how to plot this type of data on a box plot and how to compare data from 2 sources, usually looking at the median and the interquartile ranges. Lastly, we looked at histograms, which are used to display grouped data where the class intervals are of variable width. They work on the frequency density, which is used to calculate the area of the bar rather than the height. In the next video, we're going to be looking at the foundations of probability and the method of calculating the chance of something happening. I'll see you then.